Hello class, welcome to this video on the EOC review practice. So this is part 2. So let's go ahead and continue with the problems. So GR14, prove relationships and theorems about parallelograms, solve mathematical and real world problems involving postulates, relationships, and theorems. So number 1, we got quadrilateral PQRS is a parallelogram. What is angle KSP? So first off, if we look at this, since it is a parallelogram, that means that these two sides are parallel, and it also means that the QP and RS are also parallel. However, we're just going to use those two. Because this is 76 degrees, right? That means that these two angles, this angle and this angle and that angle here, like this angle here, those are, if we think of this as the sandwich model, we got our parallel lines with the transversal. And so that means that these two are same side interior angles. Okay, so these are same side interior angles, also known as consecutive interior angles. And same side interior angles are supplementary. That's the same side. That's the consecutive interior angle, theorem there. So they're supplementary, and so that means that we can add them to 180. So let's call this x. So we got x plus 76 equals 180. So that means x equals 180 minus 76, which is 104. And since this is 104, that means these have to be both 52, right? Because they're both equal. You just take 104 divided by 2, which is 52 degrees. And so now we know that those are both 52. We know that this is 90 because it says that there. And in order to find KSP, which we'll call y, a variable, we know that these three angles have to add up to 180 because we have a triangle. So we got y plus 52 plus 90 equals 180. And then this adds up to 142. Subtract that 142 from 180, and you get looks to be 38 degrees. All right. For the next problem, number 2, in the diagram below, they give you SV, which is x plus 3, VU, which is 2x minus 1, TU, which is 4x minus 3. And so we know that for a parallelogram that these opposite sides are congruent, right? And so we can only say that SV is equal to TU. So we're going to set these two equal to each other. And we'll solve for x. So in this case, I'm going to subtract x on both sides. And that leads to 3 equals 3x minus 3. Add 3 to the other side. 6 is equal to 3x. Divide by 3. X is equal to 2. And so that is x. And then don't forget to plug that into SV right here. So we get SV equals x plus 3, which is 5. All right, next one. Given the parallelogram, if df is 5x minus 1, so df is 5x minus 1. What is xf? And okay, so where is x? Oh, okay, so this is actually, hold on, let me write it over here. So this here is 5x minus 1, and then they want xf, so they want this question mark here, which I will call that, I'll just call that y. Okay, so xf is going to be y. So notice that because this is a parallelogram, that means that these two are congruent and these two components are congruent. So if that's y, this is also going to be y, right? So these are both going to be y. They're the same thing. So first we're going to set 2x is equal to 3x minus 5. So we're going to set those equal to each other because they must be congruent. Because in a parallelogram, the diagonals cut each other in half. They bisect each other. All right, so we're going to subtract 3x here to move it to the left side. So it's going to be negative x equals negative 5. So that means x is equal to 5. And now because x is 5, we can plug it into here. And we can say, okay, well, we know that df is 5x minus 1, right? So we're going to plug x into that. 5 times 5 minus 1 is 25 minus 1, which is 24. And we know that y is half of df. So we got to do half of 24. It's going to be 12. So that means that these are both 12, essentially, is what we're saying, to make a total of 24. So this is a typo. This should say 12 and not 13. So that's a typo. So make sure you fix that on your paper. Number 4, using the same diagram as in question number 3, is EG perpendicular to DF? Why or why not? So, okay, so in this case, we're just trying to see if the diagonals are perpendicular. Do we know that how do we know that the diagonals are perpendicular? Well, remember that the only quadrilaterals, right, in which the special quadrilaterals in which the diagonals are perpendicular are in a rhombus, and in a rhombus the sides are all congruent, right? If the sides are all congruent, then this is a right angle. In a square, right? So in a square, all of the sides are congruent, and then therefore the angle between the diagonals is perpendicular. So first off, from this here, which I'll go ahead and just write it out. These are both 12, and these were both. Let's see, what were they equal to? We didn't actually write down what they're equal to, but in any case, let me just go and ahead and draw this bigger one. So these were both 12, right here, 12 and 12. And then this is 5x minus 1, right? So on here, so 5, and then we got x was 5. Oh no, not that one. Hold on, I'm looking at the wrong one. 3x minus 5. Okay, so 3x minus 5. So this is 3 times 5 minus 5, which is 15 minus 5, which is 10. Okay, so that's 10, and this is 10. So 10 and 10. So these are congruent, and these are congruent. So right here, this is showing that, so since this is a parallelogram, this means that these two diagonals are not going to be congruent. They're just going to cut each other in half. The only way that we know that this is a right angle is if we know that this side is congruent. We have to know that the opposite sides or that all of the sides are congruent. So we have to know that this is congruent to this is congruent to this, but we do not know that, right? And so therefore we're going to say that it's impossible to tell. There's no way that we can tell what those sides are based on the information given. So that's going to be a no. We don't know. For number 5, what measure of angle DAB would show ABCD as a parallelogram? So for this to be a parallelogram, we know that the opposite angles are congruent. So those are going to be congruent. And we also know that, oh yeah, so that's it. We want to find DAB anyways, right? So DAB. So we want to figure out what this, we want to figure out this angle. So I'll call that angle Y. Oh no, we already have a Y. So let's just find all the angles. So we know that these two are got to be congruent. So we're going to set them equal. So 2z plus 15 is equal to 3z minus 17. So let's solve for z here. Subtract 2z on both sides. And then we'll go ahead and add 17 to the other side. So we get 32 is equal to z. So now we got z, and so we can plug it in to the angle so we can figure out what that angle is, okay? So we got, if we plug it into 2z plus 15, we got 2 times 32 plus 15. That's 64 plus 15 is 79 degrees. So these are both 79 degrees because they have to be equal. And now we know that to find this angle here, this question mark angle, we know that these two have to be the same, these opposite ones, and that these two are supplementary, which means that they add up to 180. Okay, so that means we have to do 180 minus 79 is equal to 111, and that, or 101, and that gives us this angle. Okay, so that's your answer. A measure of angle DAB is 101. All right, using the same diagram, what are the values of x and y? All right, so for this, we know that these have to be congruent and these have to be congruent because they're on opposite sides. All right, so we're going to say 2y plus 3 equals 3y minus 2. And we're going to say that 2x plus 4y, it has to be equal to 3x minus 3. And obviously it's easier to solve the left one first because there's only one variable. So we're going to solve that first. Subtract 2y on both sides. Add the 2 to the other side. So y is equal to 5. And then we're going to plug 5 into there. So that's 4 times 5 is 20. So subtract 2x on both sides, and then I'm just going to add the 3 to the other side. So 23 is equal to x. So now we know x and we know y. All right, so let's move on to the next page here. Ms. Davis gave her students all the steps of the proof below. One step is not needed. Which step is not necessary to complete the proof? All right, so first off, we are given that ABCD is a parallelogram, so that belongs there. Usually in the beginning of the proof, the first step is like the given, and then the last step is what you're trying to prove, right? So this is good, and this is good so far. Okay, so those are both good. So step 1 and step 5, so it can't be step 1, so because that one is good. All right, so let's kind of walk through the proof real quick. So for this proof, first off, what we're trying to prove that they're congruent by SSS, right? And so one of the steps of the proof is saying, okay, well, these two triangles, this side shares with itself, and therefore it must be congruent by reflexive property, because these two triangles, this triangle here and this triangle here, share that side. And so it must be congruent to itself by reflexive property. And then because it's a parallelogram, we know that these opposite sides are congruent. And so those are congruent, and then these are congruent. And so therefore by SSS, we can prove that those triangles are congruent, which is exactly what we want here. So that's exactly what we're going to need. So we need to show that the opposite sides are congruent. We need to show that the side in the middle is congruent by reflexive property in order to prove by SSS. So the only one that we do not need are the angles. We don't need the angles in order to solve this proof. So the answer is step 3 is not needed for the proof. All right, so let's move on to the next benchmark here. Prove relationships and theorems about trapezoids. Solve problems involving trapezoids. All right, so if IJ is not parallel to GH, what is the measure of angle G? So this is an isosceles trapezoid because these two sides are congruent. In an isosceles trapezoid, we know that the two angles here that are consecutive, these two top angles, or I guess they would be the bottom here, are going to be congruent. So this is going to be 116 as well. And then these ones here, the base angles essentially or the top angle. So basically the angles next to each other that are next to the bases, essentially, is what we're trying to say. These two are supplementary. So they add up to 180, and then this is congruent to that. And so we can figure out what angle G is if we know angle J or H. All right, so to find this angle, you just do 180 minus 116, which is 64 degrees. All right, number 2, it's an isosceles trapezoid, therefore these are congruent. If it's isosceles, then by definition, these two non-parallel sides have to be congruent. It says measure of angle P is 5t minus 4. So that angle there, this angle here is 5t minus 4. 74, sorry. And then what is the value of t? Well, we know that these two angles have to be congruent, so we can set 5t minus 74 equal to 136. And then we can solve that. So plus 74. All right, and then we got 5t equals, add that together, you get 210. Divide by 5 on both sides, so t is equal to 42. All right, so we got the value of t. Number 3, it's an isosceles trapezoid. So in an isosceles trapezoid, the diagonals are congruent, so they're the same length, as long as it's an isosceles trapezoid. So basically, if these two are the same length, then these two are the same length. These diagonals are going to be the same length. So I'm going to say that those two are congruent. Okay. All right. So we're going to set those equal to each other essentially. UW and VX. So 17C plus 74 equals 20C plus 71. So subtract 17C on both sides. And then I'm going to subtract 71 on both sides. So we had 3c on the right side and then 3 on the left side. Divide by 3 on both sides. So c is equal to 1. These cancel out, giving you 1. All right. So that's the value of c. Number 4, if the measure of angle BAD is 56, so that's BAD. So we're talking about this as 56. So if that's 56, then we know that since it's isosceles, this is also 56. And if that's 56, we know that these two are going to be equal. And to get these two, you have to do 180 minus 56, which is 124. These are both going to be 124. Okay, so then in that case, we're going to say that BCD is 56. BCD, no, BCD is not 56. It's 124. So this is false. AD is 4. Okay, so they said here that BC is 4. Okay, actually, let me go ahead and, because there's so much going on in this. So this angle is 124. This angle is 124. And it says BC, which is, this side is 4. Well, that side is 4, then this side is 4, right? BC is 4. AC is 6. So this whole thing is 6. Well, if that's 6, then that means that BD is also 6. So these two are congruent. All right, so BD is also 6. That's true. And if BC is 4, then AD is 4 because it's isosceles. Here ABC is not 34. ABC is 56 degrees. So that's false. ADC is 124, that's true. And then ABC is 56, that's true. All right, that takes care of that question. Number 5. VW is perpendicular to WX. So VW is perpendicular, so that means these are right angles. WX is perpendicular to XY. WX perpendicular to XY. So these are also right angles, both of those. All right, so complete the proof that VW is parallel to XY. All right, so these were given, 1 and 2. And step 3, we know that because those are perpendicular, that means that the angles are 90 degrees. And that's by the definition of perpendicular lines for both of them. Since they're perpendicular, that means that the angle has to be 90. All right, and then and in that case, if I were to add these two angles, obviously I'm going to get 180, right? By addition property. And then because these are supplementary, meaning they add up to 90, that means these two lines are parallel because of same side interior angles. If you think about it, this is my bread, toothpick. Those are same side interior angles. Same side interior angles. And so if the interior angles that are on the same side of the toothpick are congruent, or are not congruent, are supplementary, then that means that the lines are parallel. And so that theorem is the converse of the same side interior angles theorem, also known as the converse of the consecutive interior. So, or converse of consecutive interior angles theorem. Okay? Consecutive and interior and same side interior mean the same thing. All right, so another proof. Consider the proof below. Quadrilateral ABCE is an isosceles trapezoid. Okay, well then that means these are the same because the two legs have to be the same if it's isosceles trapezoid. Triangle BCD is an equilateral triangle. BCD. Well then if this side is the same as this side, these sides are all have to be the same, right? Because if this is isosceles, so by definition. So we're going to say, okay, well, by definition of isosceles trapezoid, that means that AE has to be the same as BC, and then BC has to be the same as BD because it's an equilateral triangle. And then we can say that BC is the same as, or rather we could say AE is the same thing as BD because, so if AE is the same as BC and BC is the same as BD, then that implies that AE is equal to BC, right? Or is equal to BD, logically speaking. If AE equals BC, BC equals BD, then AE equals BD. That's called a transitive property. It's a transitive property of congruence. It's called congruence because we're dealing with congruent symbols. All right, so that takes care of that one. Next one is angle E is congruence to angle C. And that's true because the base angles of an isosceles trapezoid are congruent. So base, I'm just gonna shorten this here. Base angles of isosceles trap are congruent. Isosceles trap. And then angle C is congruent to angle D. That is because it's an equilateral triangle, right? So that is the angles in an equilateral triangle are the same. So angles in equilateral triangle are congruent. And so therefore angle E is the same thing as angle D by transitive property. And then we can say, okay, well, since these are congruent, then that means that these are parallel, right? By the converse of the corresponding angles theorem. And then ABDE is a parallelogram. We can say that it's a parallelogram now because it's congruent and parallel. And therefore, by definition, actually, what we can say is not by definition. So a parallelogram so basically a quadrilateral with one pair of opposite sides congruent and parallel is a parallelogram. Okay, that's a theorem. All right, so in this case, I went through the entire proof, but we're just looking at number 5, right? It says here statement 5. So for statement 5, we know that the base angles of an isosceles trapezoid are congruent. All right, I do want to go to the entire proof just in case they ask you for a specific question on there other than step 5. All right, so next one. Select all the true statements. So for this guy, if we look at the first one, ABC and DEC. So A, B, C. So notice that we got a side here and we got an angle. But we don't know anything else about these two triangles. Therefore, we cannot say that they're congruent by SAS. So no. ABC and DEC by SSS? No. We need two other sides. So no. So we can ignore that now. AFC. So we got a side, and then we got an angle. Because this is right angle, then this is also a right angle. And then we got the side here. This side is congruent to itself by reflexive property because those two triangles share that side. So we got, okay. And then we know, first off, we know that because this is an isosceles triangle, we know it's isosceles because these two are congruent. Because it's an isosceles triangle, that means that these two angles have to be the same. So we're going to say that these two angles are identical. So it looks like we have, if we use this angle, we have angle, angle, side. So I guess we don't technically need this right here. We can say that these two are congruent by angle, angle, side. So yes, this is true by angle, angle, side. Also, keep in mind that these are right triangles. And so that means that we have the hypotenuses. The hypotenuses are the same. So we have an H here. And we know that because this is reflexive, we actually have a leg. And so by HL theorem, this is also going to be congruent. So we can also use HL theorem. All right. So again, HL theorem means you have a hypotenuse and you have a leg that is congruent in both triangles. And it has to be a right triangle. All right, so number 2, in the diagram, triangle JKL is congruent to ONM. Okay, so JK is congruent to ON, right? JK, all right, let's look at the angles. So J is congruent to O. So if this is 60, then O has to be 60. And then K has to be congruent to angle N. So this has to be congruent to this. And then L has to be congruent to M. And so that means this is 56. And we're looking for angle N here, right? So we know that angle N and these two angles add up to 180 because it's a triangle. And so this here is 116. And so I'm going to subtract from 116 on both sides to get 64 degrees. So the measure of angle N equals 64. All right, so for number 3, what is WZ? Okay, so this one's kind of interesting because there's a lot going on in this problem. So I'm going to try to break it down as best as I can. So what I'm going to do is I'm going to call this X. I'm going to call this side X, okay? And then I'm going to call this side here, this entire side, I'm going to call that Y. All right, and then I'm going to call this side, I'm going to call it Z. Okay, because we're going to need some variables. And we are trying to look for WZ, so we're trying to look for this. So that's the question mark right there. But we're going to be able to find that by finding these other variables. So first off, let's go ahead. Okay, so first off, let's just focus on this triangle. And we know that according to the angle bisector theorem, for the triangle angle bisector theorem, it states that these two, so basically this is what it states. So if I were to have a triangle with an angle bisector here, where this angle cuts that angle in, this line cuts this angle in half, so that's an angle bisector. And so if we have something like this, then we know that A is proportional to B and C is proportional to D. So then we would say A is to B as C is to D. So that's how we set that up. So if I just focus on this triangle and use that, we would say that 4 is proportional to X, right? So 4 is proportional to X as, so 4 is to X as 6 is to 3. And that's how we would get X. All right, so yeah, so that's how we would get X. And then so we're going to cross multiply we got 6x is equal to 12. So that means x is equal to 2. So now we know that that's 2. All right, and then what we're going to do, now we're going to look at both triangles, and we're going to use them to find y, all right, or to find z. So we know that this whole thing is 5, and so if I were to compare this, then we know that 5 is proportional to z. So 5 is proportional to z, as 6 is proportional to 9. Okay, just by comparing those two triangles. As 6 is proportional to 9. And so then I can cross multiply here. In that case, I get 6z equals 45. And then divide by 6. So z is equal to 7.5. So now we know that this is 7.5. And then if I find y, then I can find wz. So that's the idea. That's what we're trying to go for. All right, so now let's go ahead and find y. So to get y, we know that 3, we can basically say that if we just compare these two triangles, meaning just these two, this triangle and this triangle. So if we just compare those two triangles, we can say that 6 is to 9 as 3 is to y, right? So we can say 6 is to 9 as 3 is to y. And if I cross multiply, I get 6y equals 27. If I divide by 6, y is equal to 4.5. And so now we know that this is 4.5. And now we can figure out what WZ is, because WZ is just 7.5 minus 4.5, okay? So that's how we get the question mark. So WZ is 7.5 minus 4.5, which is 3. Okay, so for number 4, SU and RT bisect each other. Select all the theorems that can be used to show that those two triangles are congruent. So SU and RT. So we're going to need to, I feel like, did we do this problem already? We might not. I don't remember if we did that problem. Okay, so we got, let's go ahead and let's call this SU. And let's make SU like this. Let's call that SU. And then we'll call this RT, and they cut each other in half. So this is cut in half, this is cut in half. And obviously this has to be point V, because this is triangle T, hold on, let me make sure I got this right. So we got RT, yeah, RT, and it should be the, okay, so it should be RT and SU. Okay, that makes more sense because they said TUV and RSV. So now we got RSV and TUV. So we got two triangles that meet that, and they cut each other in half, those two sides. Okay, so now based on these triangles, we see that so the picture's worth 1,000 words here, guys. So what you want to do is, now that we got the picture, we can say, okay, well, these are congruent because they're vertical angles. And then, so therefore angle, or no, sorry, we got side, angle, side, side, angle, side. And that's your answer. And there's only one answer there. It's side, angle, side, because you don't have any other angles, you don't have any other sides. All right, so that's it for number 4. Number 5, what is JL? All right, so this one can be a little confusing if you are not used to this sort of thing. We have a bunch of similar triangles here. There's actually 3 triangles that are like 2 different pairs or whatever of similar triangles. But we want to figure out what JL is. So first off, we need to, in order to figure out what JL is, we have to know what, let's call this X. We would have to know what that is, and then we can add these together, right, to get that. So what I'm going to do is I'm going to use this triangle here, and I'm going to say that that triangle is similar to this triangle over here. Okay, so I'm going to claim that those are going to be similar to each other. All right, and I'm color coding it so that you can see what the numbers are for. So how do I draw? So basically I need to know which sides correspond to each other because these are similar, but it's kind of hard to tell. All right, so first off, we know that this has to be a right angle because this is a right angle, right? And this angle here actually corresponds to this angle here. And this angle corresponds to this angle. Okay, and you can kind of tell that from the picture. Essentially, yeah, you can kind of tell that from the picture. The other way that you can tell is that we know that this side corresponds to this side. They're not congruent. I'm not indicating that they're congruent in any way. I'm saying that these correspond to each other, so I'm not using a tick mark here. I'm using a squiggly just to kind of say, hey, you know, they're kind of similar, right? They are similar because this is a hypotenuse and this is also hypotenuse. So what I'm going to say is basically I'm going to draw these two triangles just to kind of show you. So the red one and I'm going to draw, yeah, so basically I'm going to rotate this so that J is on top and K is on bottom. So can you kind of tell I rotated this so that J is on top, K is on, and K is on bottom, and then M is over here, the right angle. And we know from there that this is 8 in that case. So let's just call it a red 8, and this is a right angle. And let's draw this one just the way it is. KML. This is a right angle. This is 6. And this is X, right? Okay, and so what we were saying is that these kind of correspond to each other. Well, you can kind of tell. I don't have to mark that anymore because they're lined up. All right, so they're lined up so we can tell. So what we're saying is that triangle JMK is similar to triangle KML. All right, so now we can set up the fractions, okay? So we can solve. So we can say that 8 is proportional to 6 as, and this is 6 over here, MK is 6, right? So I forgot to label that 6. As 6 is proportional to X. And that's how we set it up. So basically we have to kind of like draw it out, figure which sides are, you know, correspond, and then set up the fractions. And so now we can cross multiply and solve. So we got 8 times X equals 6 times 6. Divide by 8 on both sides, and that'll give us X, which is 4.5. And so now we know this is 4.5. So we can get the whole thing and add them together. JL is 8 plus 4.5, which is 12.5. All right. So that's how we get number 5. All right, number 6. We're going to kind of use number 6 in order to do, or number 5 in order to do number 6 because they're very similar. They're the same type of problem. Write a proportion that you can use to find the value of A, then find that value. So what we're going to do is we're going to look at, let's go ahead and just call this LKJ. I'm going to give it some letters so that we can kind of reference it, just the way we did here, LKJ. I'm going to use those same letters. And we'll call this K, we'll call this point M, so KMJ. All right, so what we're going to do is I'm just going to draw I'm going to use this triangle here, LKJ. I'm going to draw it here. Okay, and this side is A, this side is 18. And I'm going to compare that to KMJ. I'm going to compare that to this triangle. Okay, KMJ. So and this is a right angle here. So what I'm going to do is I'm going to essentially flip this that way. So K is on top and M is on the bottom. Okay, so K is on top, M is on the bottom, and then the J is just kind of still there. Okay. And we can tell that KJ and LJ are both hypotenuses. So now they're all lined up. You see how I lined it up that way? And so we know that KJ was A. And then we know that MJ is 16. And now this is perfectly lined up. You see how I lined it up? And so now we can say, okay, now we can say that 18 is proportional to A, as A is proportional to 16. Then we can cross multiply and all that good stuff. So we got A times A is A squared. And then 18 equals 18 times 16. So we need to figure out what 18 times 16 is. Actually, what we're going to do is we're just going to take the square root. So let's take the square root of both sides. So we get A is equal to square root of 18 times 16. Now, the square root of 16 is 4, right? What we could do is we could split this up into two things. We could split it up into the 16 and then the 18. Notice I switched to 16 and the 18. It doesn't matter. The square root of 16 is 4. And then we're going to just split up the square root of 18. You remember how I showed you how to split the radical? Well, we're going to do that here. So split this, simplify that. 9 times 2, 3 times 3. Oh, we got ourselves a pair, so that's going to be kicked out. And then the 2 is going to remain on the inside. So 3 is on the outside. However, we got to multiply that with the 4. So we got 4 times 3, and then the 2 remains on the inside. 4 times 3 is 12. So that is A. A is equal to 12 square root of 2. Actually, I'm just going to box this as my answer. So that's A. All right, so that was pretty tricky. That's pretty tough because you have to actually draw the triangles and then use that to kind of set up the problem. And it's kind of hard to visualize it. All right, so here it says, Rachel placed a mirror on the ground 20 feet from the base of the lamppost. So it's 20 feet here from there to there. It says Rachel's eyes are 5 feet 6 inches above the ground. Okay, so from here to here is 5 feet 6 inches. 5 feet and 6 inches, guys, is the same thing as 5.5 feet. Okay, so practice that. We know that there's 12 inches in a foot, and so 6 over 12 is 0.5. Okay, so this is 5.5 feet, 5.5 feet. We want to keep the units the same, so that's why I'm doing 5.5 feet. All right. And then it says she steps back 4 feet. So that, okay, so she stepped back away 4 feet from the mirror. All right, and we're trying to figure out what the height of the lamppost is. Okay, so interesting. So since we have similar triangles here, you can see that these are both right triangles, right? So we got a right triangle here and a right triangle here. So we can say that 5.5 is proportional to h as 4 is proportional to 20. And so we can cross multiply here. So we get 4 times h equals, and then 5.5 times 20. 5.5 times 20 is 110. And then we're going to divide by 4 on both sides. So h is equal to 27.5 feet. So that's how tall the lamppost is. All right, so let's move on to the next problem here, our next page. So given a pre-image and an image, describe the transformation and represent the transformation algebraically using coordinates. Okay, so in this case, if we look at this, let's just take a look at G and G prime just to make it easy, okay? So G is -4 and -6. And G prime is -6 and 4. And so you can kind of see what the rule is. The rule is that if this is x and this is y, they are basically being switched, right? So y is now first, and then x is second. However, the x changed sign from negative to positive, so that means there's a negative here. That's the rule for rotation set 270 degrees counterclockwise, is xy goes to y negative x. So that is our answer. That's what we're looking for, y negative x. And we just use this to kind of verify that. All right, number 2, v prime, w prime, x prime is a translation. Write the translation rule. So we're going from w to, or v to v prime. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. So we're 8 to the right. 1, 2, 3, 4, 5, 6, 7. 7 down. So that means we're adding 8 and then taking away 7. We're adding 8 to the x, and we're taking away from the 7, because 7 down is negative. All right, and that's our translation rule. Pretty straightforward. All right, number 3, given AB with those coordinates and A prime, B prime with those coordinates, which translation was used? This is a typo, by the way. These should all have it should just be x and y, not x prime, y prime. So that's a typo. So just ignore the primes there. There's nothing there. So we're going from A to A prime. And so basically we're going from -3, -1 to -1, 2. So you can kind of see, in order to get from -3 to -1, I have to add 2. To get from -1 to 2, I have to add 3. 3 plus -1. So we need to add to the x coordinate and add to the y coordinate. So the answer is B. All right, number 4, point F prime is the image when point F is reflected over the line x equals -2 and then over x, y equals 3. The location of F prime is 3, 7. Which of the following is the location of point F? So I'm going to kind of just show you how to do this by doing a graph. It says point F prime is 3, 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So that's F prime. We have x is equal to -2. X is equal to -2 is a vertical line, guys. So x equals -2 is this vertical line. Okay, x equals a number is vertical, y equals a number is horizontal. So this is y equals 3 is horizontal. So that's y equal to 3. All right, so it says that F prime is the image when point F is reflected. So point F is reflected over x equals -2. And we'll call that point G. And then point G is then reflected over y equals 3, which leads to F prime. So you're going for F to F prime by doing those two transformations. So in order to go from F prime to F, we got to go backwards, guys. Right? So we got to reflect by y equals 3 and then reflect about x equals -2. And that'll give us back to F, which is what we wanted. All right? So this is my F prime. I need to go reflect across y equals 3 first. So it's 1, 2, 3, 4. So then I got to go 4 down. I got to go the same distance on the other side. 1, 2, 3, 4. So this is -1. So this is my point G. All right, so it's 4 here, 4 here. So that's G. And then I got to go reflect across x equals -2. That's 1, 2, 3, 4, 5. So I got to go 5 on the other side. 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5, 6, 7. So this is a x value of 7 here. And this is where my point F is. And notice that F is -1 and -7. Or -7, -1, sorry. X first and then Y. So that's my F. And so if I do it backwards, it says I got to take F, reflect it over x equals -2, reflect it over y equals 3, and that gives me my F prime. So that's the right answer. Good to check your answer every once in a while. The answer is A. All right, so let's try to do a few more of these problems, and then we'll end this part of the video. And then we'll call this part 2. All right, so GR22, identify transformations that do or do not preserve distance. So which of the following transformations would not preserve the angle measure in the image? Okay, so first off, if we look at number 1, this is a dilation, right? Because we have the same scale factor. So we have dilation where K is 2.5. So basically it got bigger. This is a stretch. It got bigger. This is a translation. Translations do nothing to change the angle or the size. Okay, so dilations only change the size. So this changes the size. This changes the angle or the size, not the angle. Or I'm sorry, the translation doesn't change anything. So changes size, not angle. Translation changes neither. This is a rotation. Rotations don't change anything. Changes neither. And then this here, this is not any of them because this is a scale factor. This is being multiplied by 2 and this is being multiplied by 4. So this changes the angle. This changes both size and angle. So this would be the answer. It doesn't preserve the angle. All right, so number 2, a triangle has vertices at those points. Which transformation will produce an image in which the angles or the sides are not preserved? So, okay, so you can't, you have to, you can't preserve either the angles or the sides. All right, so here, reflection over the x-axis. Reflections don't change anything. So changes neither. Rotations, also same thing. It doesn't change, it changes neither. So there can't be these. Dilations change the angles. So yes. A transformation which doubles x and halves y, this changes both size and angle. So therefore, it's going to be C and D. Now, if it said the transformation doubles x and doubles y, that would only change the angle. Or that would change just the size and not the angle, right? But here it does both. All right, so number 3, which transformation will always produce a congruent figure? Anything that produces a congruent figure has to be a rotation or a translation or a reflection. Any of those things do not always produce a congruent figure. So this is a translation. So that is going to be an answer. This is not this is not a dilation, but it's a type of stretch, right? X is getting more bigger by 2 times. This is not either of those. This is actually a combination, and this is a dilation. So the answer is A. Dilations never produce congruent figures here. Number 4, a figure undergoes a translation, reflection, and a dilation. Will the image be similar to the original figure? So they're not asking about congruence, they're asking about similar. So similar is when the size is different and proportional, right? So that's what a dilation does. A dilation takes a figure and stretches it out and makes it proportional. So if this were 8, then this is 16. If this is 4, then if this is, for example, 5, then this will be 10. If this is 12, then this will be 24. It basically multiplies by the same amount, right? And so it makes it similar. Anything with a dilation is going to make it similar. So the answer is yes. Any number of rigid motions and dilations will produce a similar image. That's your answer. And then this is a copy of of that question. So we already know the answer to that. It's going to be B. So I didn't mean to put that extra question there. This one. The vertices, okay, so they give you the vertices. Under which transformation is the image not congruent, or the image is not congruent? So not congruent means it has to be like a dilation of some sort. So translation, no. Rotation, no. Reflection, no. Has to be a dilation. All right, so let's go to the next Actually, we'll go ahead and end it here. So we'll go ahead and end this part here, guys. This is parts 2. I'm going to go ahead and continue with the other parts. Thank you for watching this video, and as usual, I'll see you in the next one.